You can use your calculator to do. The other one you have to use, it is not in your calculator. All right, so because of that, we're going to go over it so you know how to do it. I'm going to show you how to do it on the computer, but as far as test goes, I'm not going to actually have you find the probability. I'm just going to ask you questions to get it set up, and I'll show you what that looks like in just a little bit here. Okay, this hypergeometric distribution though for 4.5, to have a hypergeometric experiment, okay, the biggest part is you are taking samples from 2 different groups. All right, that is the biggest part. That is the only distribution where you're going to have two different parts. Okay, so for example, if I took a hypergeometric distribution of you guys, we could split you into juniors and seniors. We could split you into guys and girls. Okay, it's always 2 different groups. Okay, from the rest of it, from what I understand, they all fit. Okay, but the most important characteristic is that first one. Okay, the group that you have the most interest in is always your first group. Your sample is always without replacement for the combined groups. All right, and each pick is not independent. But like I said, the most important part for this is you're going to have 2 groups for this. All right, so we're going to do a couple examples here. And these are the sorts of questions that you would be asked on a test. Okay, I'm going to show you how to find the actual probability on the next slide. But this would be more like what your test questions are going to be. So you're president of an organization that needs to select a committee of 7 students from a group consisting of 18 women and 15 men. You are interested in how many of the selections would be men. Okay, so we're going to answer those questions in just a minute. Okay, I know some of you really want to get this down into your notes. Abigail, thanks for coming. I only talked to you about track yesterday.
I was trying to tell you to manipulate, but then you kept trying to say track.
Oh. Okay.
That was the original reason why I was talking to you.
Oh, gotcha. Guys, get these down, especially if you're taking notes on this stuff, so we can keep rolling here. No, McKenna said you messed stuff up yesterday. Oh, okay. Okay, McKenna didn't want to throw you under the bus by saying that. I'm pretty sure I could show you. Wasn't that you?
No, I never said anything to you. I wasn't even here when you guys talked about it.
I said it earlier.
I know, didn't you watch the video? For the last lesson that I taught last week?
Next time, maybe change your mind.
All right, so we have our situation up there. All right, so to answer these different questions, all right, I think of this common sense wise. All right, you are in charge of getting a committee of 7 students together. You have your groups there. All right, because we have 2 groups, This is a hypergeometric situation. All right, from there, is this going to be with replacement or without? Why? Right, you're not going to put the same person on the committee twice. All right, so that is without. A lot of the times they will tell you, but in a situation like this, just based on what we just said, that's not even needed to be told there. All right, what is the group of interest here? Yeah, we want to know how many of the selections would be men. All right, how many are in that group of interest? There's 15 men. How many are in the other group? There's 18. All right, X equals men on the committee. What values does X take on? Men on the committee. So, in other words, what are the possible numbers that we could have for men on the committee? 1 through 7? 0 through 7. What values could X take on? X stands for number of men on the committee. So there's 7 people on the committee, so it could be up to 7, but it also could be 0 there. Okay, so, all right. Any questions at all there? All right, are we good to go on?
Yeah.
All right, so this is one where I'm going to show you what you're going to have to do this. Like I said, this one is not on your calculator. So I'm going to show you a different way to get there. All right, so go ahead, copy it down. We've got a school site committee that is to be chosen randomly from 6 men and 5 women. If the committee is going to consist of 4 members chosen randomly, what's the probability that 2 of them are men? All right, so to do this one, because this is not in any of the calculators that you guys have, it doesn't matter what brand you have. I don't have it on either the TI-84, 83, or the TI Inspire. You're gonna have to come up with a different way to do it, all right? So what I did was I just did a quick search for hypergeometric distribution calculator. And then I came up with what the first thing that popped up was this calculator that we have on the side here. All right, now, how you type this in, okay, is the first line for this is population size. What is our total population for this? How many total people do we have that could be chosen here? We would have 11, right? Okay. All right, for the next one, number of successes in the population. So a success stands for the total, or what we're looking for. What are we looking for? we're looking for 2 of them being men. So the number of successes in the population, how many men do we have is really what that's saying. We have 6 of them. Okay, our sample size is 4 because we want to know how many are going to be chosen for this. And then number of successes in the sample. What are we looking for? We're looking for 2 of them. Okay, you hit calculate. And this one is kind of nice because this one gives you a whole bunch of different answers here. If you're looking for exactly 2, it gives you the percentage, which would be 45% there. Okay, it also gives us a couple other things. If it said up to 2, okay, up to 2 would be X less than or equal to 2, would be 65%. Okay, if it said something about, you know, no more than, or where 2 was not included, we would have that percentage. It would also be when it's greater than or equal to also. All right. So like I said, for this one, I just typed it in, hypergeometric distribution calculator. Okay, and that's how I got there. As far as the test goes, because I won't give you access to this, you know, I would just ask you certain questions like we did on the last page. All right. Now, for the second question, though, how many men do you expect to be on the committee? Expect is similar to what? The mean. Very good. Okay. All right. And the equation for this, and this is one that, that it's just what your equation is. So our mean, remember that's our, that is not how you write that thing. Try that again. We have a U with a tail on both sides, right? So that's our mu. All right, and the equation to find that would be NR over R plus B. And you're going, that's great. I don't know what any of those variables stand for. All right, so let's start with our N. Our N is going to be, that would make sense, but it's not. Okay, it is the number on, in this case, the number on the committee. So the number that can be chosen. Our R would be the number of successes. And then we need our B value, which is the number of, we're going to call it failures in this case. All right, so, and that's all we need for this. So, number that can be chosen, how many can be chosen for this? 4, yep. So we're throwing our 4 in there. Our R, how many successes could we have? For this, we're trying to find how many men, right? So that would be our 6. Okay, down below again, R would be 6. Plus, ladies, I'm sorry, this is just what the book says. Okay, number of failures would be our 5 here. Okay, Hope, question. The number of possible successes for this. Okay, so N, you're right, is the number that can be chosen for this committee. This would be the total number of, for this one, this would be the total number of men that could be chosen. And then B, in this case, I already apologize. Don't look at me that way. All right, B happens to be the number of women that can be chosen for this. So we just multiply add, and divide. So we end up with our expected value for this would be 2.18. Now, if you think about this like a little bit common sense wise, okay, there's a little bit over half of the people who could be chosen would be men, right? So if there's 4 committee spots, we would expect a little bit over half of that to be filled by men for this. All right, so it would make this answer would make sense for it, but that's the equation on how to figure it out. Okay, Autumn, question. The answer to the first one was 45%. All right, any questions here? So, if you're asked for this first question here where you absolutely have to find the probability, for this, you're going to have to find one of the calculators on the internet to be able to solve that. Okay, for the expected value, there's our equation up there for it. All right, 4.6 then. Oh no, I gave you a day off on Monday. Most of you didn't get your homework done during that class. I'm sorry. That's good. It was a little bit long, yeah. I did? I didn't mean to. Well, I apologize. I thought I looked through it really close and there was nothing on there, but I'll have to look again. It was like the last one? Yeah, when you're given a geometric. Yeah. All right, next one is called Poisson distribution. All right. What's wrong with that? That's how you say it. It's one of the things that I remember from stats. It is Poisson. I don't know why I remember that, but because it's the guy's name. But it's who made the situation.
It's just like random theory, you know, without how to capitalize, you know.
Yes. It's the guy's name. I don't think so. You want me to go ask her? I don't remember why I got to talk to her, but I've got to talk to her about something else. Oh boy. All right, so Poisson experiment, the biggest thing, okay? So this is the 4th one that we've talked about this chapter, all right? A big thing that I would want to know is when do I use each one, all right? So for the last one, it's when we had 2 separate groups and we're looking for one of the groups, okay? For this one, for the Poisson distribution, this is when there is a fixed interval, okay? That's why I capitalized it, all right? So that you know that's what you're looking for. If there is a fixed interval in there, you're using the Poisson distribution. Now, the Poisson distribution may be used to approximate the binomial if the probability of success is very small. Okay, I put 1% down there. It doesn't have to be exactly 1%, but it's just a very small percentage. And the number of trials is large. Okay, I put 1,000, it could be anything. Okay, I mean, you know, it can be small, or it can be, you know, maybe it's 100 trials. Okay, maybe it's 1,000,000 trials. Anytime where the number of trials is fairly big, you can use this for. Okay, Abigail? I just said that. I don't know. I mean, I put down just as an example 1,000 different trials. Okay, it could be maybe a couple hundred trials. Okay, if you have 27 trials, is that a large number? No, I wouldn't think so. I would say it's got to be at least 100. Okay, that makes sense, Abigail?
So like 3%, would it be like 1% or like a little bit higher?
It could be a little bit higher than 1%. That's just an example. So it could be maybe 1, 2, 3%. Okay, but once you get into the 75%, that's not going to work, right? Okay, so something fairly small for successes, and then number of trials is fairly large. Okay, so there is a little bit of wiggle room with that. Okay, but like I said, keywords. If there's a fixed interval, this is what you're going to use here. Okay, nice thing for this is it is in the calculator. The Poisson distribution is built in there. So we're going to talk about that in a second here. All right, this one. This one is on the easier side. It's up to you. Average number of loaves of bread put on a shelf in a bakery in a half-hour period is 12. Of interest is the number of loaves put on the shelf in 5 minutes. The time interval is 5 minutes. Okay, and there's our interval that's telling us that we're doing the Poisson distribution here. And how many loaves are expected to be placed on a shelf during that time? All right, so once again, expected value. That's kind of like our mean, right? Okay, now how we find that for this one is we are missing a number. Never mind, no, we're not. The number is up there. I just didn't pay attention to it. Okay, so I'll let people finish writing it down before we figure this out. All right, so as I said, this question, how many loaves are expected? That is talking about the expected value then. So we're trying to find what? We're trying to find our mu again. All right, for this one, what it's going to end up being is the equation ends up being the interval over the total times the total during that time. And I'm going to explain this, what those individually mean here. All right, so our interval was how long? 5 minutes. So that's going to be our top number here. Because that is talking about 5 minutes, the bottom has to do with how long is the total period in this problem? 30 minutes, because it says half hour up here, right? So this would be 5 over 30. And then the total number of items during that time. So during that 30-minute period, how many were put on the shelf? 12. Okay. So then we just multiply this out. 5 times 12 is 60 divided by 30. Means that during those 5 minutes, there are going to be 2 loaves placed on the shelf. All right, so another equation. All right, you just got to know how to use it. Okay, any questions there? All right, next one. Now this is where we would actually use our Poisson distribution. All right, according to Baden, an email management company, an email user gets on average 147 emails per day. From there, we can just answer different questions based on that. All right, and this one is in your calculator. So that first question, what is the probability that an email user receives exactly 160 emails per day? All right, so remember what that's going to look like is we're going to say the probability of X being exactly 160. Okay, so for this, what we're going to use when it's exactly, remember there's 2 different types. There's a PDF and a CDF. Which one do we use when it's exactly that number? PDF. So you're going to go down and you're going to look for your Poisson distribution and you're going to go to the PDF. All right. And I haven't done it on the Inspires, so I assume it's fairly similar to what we did before. But on the TI, the other ones, okay, you just type in what they ask for. All right, so Poisson PDF, okay. The first one is this one that looks like that, okay. That is your average number, so that's the 147. The X value is always what you're looking for, so that's the 160. So we type in 147 for the first one, 160 for the second one, and we hit enter, and we get approximately 1.8%. Okay, it is pretty low. All right, and we're going to see why in just a minute when we figure out what standard deviation is. Okay, we should be able to figure that out. Okay, for the next one, what's the probability that an email user received at most 160? All right, so if we set this up the way we did up above, that's going to be the probability. X, is it going to be greater than or less than at most 160? Less than, could it be equal to? Yeah. Okay, so X less than or equal to 160. All right, for this one, you're still going to go find your Poisson. And then this would be a CDF because of the less than then. All right, and you type it in the exact same way. All right, the 147 is your top value, the 160 is your other one, and you get an answer of, for this one, 86.7%. Okay, now if this one said at least 160, that would be, so for at least, that would be when X is greater than 160. You're still doing the CDF. We're just going to have to take 1 minus our answer here to be able to get this. So this would be about 13.3%. Okay, so just be aware of that. Same thing that we talked about last week with these when they changed the wordage for this. All right, what is the standard deviation? As Eli said, that percentage right away was pretty low, okay? The reason for it is how we find our standard deviation. Standard deviation of a sample is just the square root of our expected value, okay? Our expected value here would be 147. So we just take the square root of 147, and that ends up being 12.1 for that. Okay, so that's one reason why it's as low as what it is here. All right, any questions? All right, last one here. This one asks you just something a little bit different, okay? Read it. I don't know how important this one is to have notes down for this. I think if you just follow along with what we're doing here, you should be good. All right, probability of low seismic activity for the next 48 hours. There's our interval, right? Our interval is the 48 hours. Was reported as about 1.02%. Use the information for the next 200 days to find the probability that there will be low seismic activity in 10 of those 200 days. Use both the binomial and the Poisson distributions to calculate the probabilities. All right, so first of all, it says we need to use our binomial probability, okay? You're just gonna use the one in your calculator where we did that, okay? So for this, are we finding exactly a number or up to a number? And what is that number? It's exactly 10, all right? So for this, what we're truly finding is we're finding the probability that x equals 10 here. So because it's equal, we're going to use the binomial one, and it's going to be, because it's equal, it's going to be PDF. Okay, the numbers that we would throw in there would be 200. Okay, and Elena, I'm pretty sure on your calculator, you're going to have to type it in the way I'm going to write this here. Okay, 200, because that's the total number of days in the study. All right, and then the probability would be the 1.02%. So we change that to a decimal. And then how many are we looking for? We're looking for 10. Okay, in both the yellow calculators and the Inspires, you're going to have the spots for those. Okay, this answer is really small, isn't it? 0.0039%, I think is what I got. Okay, now, what this one is saying, though, is we need to compare both the binomial and the Poisson here. All right, so we're going to do the same thing. We're going to use the Poisson PDF. Okay, and this one, before we type this into our calculator, do we have an expected value for this? No, we don't. So we're going to have to find that expected value first. To find our expected value for this, remember the expected value is our mu. Okay, that is when we're taking our n times p. Our n stands for the total number in our situation. So that would be 200 times that probability. So 0.0102 per, when we change that to a decimal. And that would be approximately 2.04. Okay, if you look back on our last one here, okay, they gave us what the expected value was. Okay, if we look on the one before that, they gave us what the expected was. All right, which was, okay, right there. All right, for this, we're going to have to find it. So for that, for our Poisson, we're going to have our expected value of 2.04, and we want to find exactly 10. What we get for an answer for that one is 0.0045%. Okay. Are they close? Yeah, there's just a tiny little bit of difference between them. All right, so make sure when you do these sorts of problems here, you're gonna have to find these individual percentages, okay? And then the answer is either yes or no. All right, questions there?